Okay, I'm showing 9 o'clock. Let's review factoring trinomials. Now remember, trinomials, tri just means 3, and nomials means numbers, 3 numbers. The one thing I forgot to tell you the other day was we always want to set this equal to 0. So if there's a number over here, like 3x squared plus 7x minus 2 equals 5, we want to subtract 5 from each side, set this equal to 0, and we get 3x squared plus 7x minus 7, okay, equals 0. That really doesn't come into play until we're going to do later. Now let me, excuse me, let me review something here real quick. If we have factoring trinomials, they love this stuff in algebra. If we have a squared plus 10a plus 21, what we want to do is, what are the factors of 21? Factors means what number times another number. Up together to give us 10. Everything's positive here, so it's going to be in the form. Well, can you be more stupid? It's going to be in the form a plus some number and a plus, both are going to be pluses, some number. But what we want to do here is we want to take the factors of 21, and being that everything's going to be positive here. 1 times 21, 3 times 7, I think that's all. And 3 and 7. 3 and 7 add up to 10, so that's what we want. A plus 3 times a plus 7. If you want to double check and eat, well, can I be more stupid? Sorry. Do this over again. If we have a squared plus 10a plus 21, everything in here is positive, so it's going to be a plus something and a plus something. Okay, that's the form that the end product is going to be in. Now we want to take the factors of 21, the factors of 21 add up to 10. So we have 1 times 21, 2, 3 times 7, that's it there. 3 plus 7 is 10. So this is what we're going to end up with. A plus 3, a plus 7. If you did the distributive property here, you'd end up with that. Now, an easy way of checking this is 3 times 7 is 21. 3 plus 7 is 10. So we're right. Let's see. Let's see if I can find an easy one here. Okay, how about this? X squared minus 9x plus 8. Okay, now when the linear term, the middle term is negative, this one's positive. This is going to be x minus something and x minus something. Because remember, the last thing we do is we multiply this number times that number, and a negative times a negative is going to be a positive. I hope that makes sense. Take a drink of Diet Coke. Now we want the factors of 8 combined together to give us negative 9. Negative 1 times negative 8. That's it there, isn't it? Negative 2 times negative 4. That's all. It's that. Negative 1 and negative 8. It's going to end up being x minus 1 times x minus 8. Again, to double check, negative 1 times negative 8 is positive 8. And negative 1 and negative 8 is negative 9. So we're correct. Are they okay? Okay. The numbers get a little bit bigger, but really they're not any more difficult. Okay, now, everything we've done so far, coefficient of the quadratic term. Doesn't that sound odd? The coefficient of the quadratic term. It makes up these words. Okay. It's been 1. Right. Now, what happens if they're not 1? Now, this is going to... I sent you a sheet on this. When A is greater... This is an A here. Is greater than 1. Remember, number in front of the quadratic term is A. When that is more than 1, this is the procedure that you use. First of all, you set it equal to 0. I sent you a sheet on this, so you don't necessarily have to write this down unless you want to. Number 2 is you multiply A times C. This number is this number. Number 3, you factor F-A-C-T-O-R A times C. We're going to rewrite linear term. Now the linear term is this one, the one in the middle. I know this doesn't make a lot of sense right now, but it should, or it will. We're going to group. Remember a couple of days ago we did this grouping stuff? Well, here we're going to group them together. Group and factor A-C-T-O-R. And number 6 is we rewrite the factors. Rewrite the factors. This is how we excuse me. This is how we factor a trinomial when the coefficient of the quadratic term. This is called the quadratic term. Again, I sent you a sheet on this, and it kind of explains that quadratic term, the linear term, and the constant. Okay, so what if we have this? This you're so smart. Okay, if we have 2x squared plus 7x plus 6. Now everything, all the terms in here are positive, so it's going to look like this. It'll be in the form x plus a number and x plus a number. Okay. Now remember, the first thing we do is we multiply A times C. A, this is A, B, and C. So A times C is 2 times 6, which is 12. Now, we want the factors of 12 that add up to sevens, just like we did in the other form. This was 1. 1 times 12, 2 times 6, 3 times 4. There it is. Right? 3 times 4 is 12. 3 plus 4 is 7. Now we're going to rewrite the linear term. We're going to take the linear term and we're going to split it up into 2x squared plus 4x. Okay, I'm going to put the 4 next to the 2 because we're going to end up factoring these. Okay? Plus 3x plus 6. Now again, this 4x and 3x is 7x. We're just splitting this up into these two terms. Right with me? Okay. Now what we're going to do is we're going to group them together. We're going to group this one and this one, and of course equals 0. Equals 0. Okay? Now remember the other day when we did grouping. Now what is it that we can, excuse me, what is it that we can factor out of each one of these terms? A 2 and x, right? We can take an x out of there. 2x times what is 2x squared? X plus 2. Now I tell you, I always do this backwards because I'm stupid, and it'll get away from you if you don't watch out. 2x times x is x squared. That's right. 2x times 2 is 4x. So we're right. Now, what can we factor out of this binomial here? 3. 3 is a factor of both of these terms. X plus 2. Now, remember what we said the other day? These two terms must be the same. If they're not, something went wrong. Now we have this plus this, 2x plus 3, times x plus 2. Remember, we only use one of these, not both of them. Equals 0. Right, and that's our answer. It's really pretty simple. The only difference here is we take the linear term, the middle term, and we split it up into these two. And then we group, that groupage thing, and factor. Take a drink, you Diet Coke. Okay. Okay, get this. 4b squared plus 12b plus 9. Now again, all the terms in here are positive, so it's the form will be b plus something times b plus something. We do a times c. There's an a here. My handwriting's getting worse. It was bad enough when I was young. Now I'm old. It's even worse. A times c is 4 times 9, which is, what is it, 36? Now, what are the factors of 36 that add up to 12? 1 times 36? No. 2 times 18? No. 3 times 12? No. 4 times 9? 4 times 9? No. And 6 times 6? Yes. Okay? Now again, what we're going to do is we're going to split this linear term up into two terms. So we're going to get 4b squared plus 6b plus 6b. Okay, we're taking both of these and we're splitting up this linear term. Plus 9. Okay? Now, group them, equals 0, equals 0. Okay? Now, what can we factor out of these two terms? Like 2b, huh? Be or not to be. 2b times 2b plus 3. 2b times 2b is 4b squared, that's right. 2b times 3 is 6b, that's right. Plus, what can we factor out of here? Looks like a 3, huh? Open. 2b plus 3 equals 0. And remember, these two have to be the same. If they're not, something went wrong. So now we have 2b plus 3 times 2b plus 3 equals 0. Now what you might see on the final exam is you might see this thing here. Is there another way we can write this? These two things are the same, right? So we could write it 2b plus 3 squared. Same thing. It's the same thing. Doesn't make any difference to me, but you're going to find somebody where that it will mean something to. Okay. Is everybody okay? Going too fast. Please tell me if I'm too fast. Oh, wait a minute. Today, Thursday? Ooh, date night. And she's good looking. Okay. Get this if you're so smart. 5m squared plus 12m plus 4 equals 0. Okay. Now the first thing we're going to do, and again, everything's positive in here, so it's going to be m plus something times m plus something. Now we do a times c is, what is that, 5 times 4? Which is 20. What are the factors of 20 that add up to 12? 1 times 20? No. 2 times 10? That's it there, isn't it? We don't have to go any further. That's 2 and 10. Now, which one of the factors? Remember, we're going to take the linear term here. We're going to split it up into these two factors. Now, which one do we want to put next to the 5? The 10, right? Because 10 and 5 are factors. 10 is a factor of 5. So we put 5m squared plus 10m plus 2m. Now remember, all we're doing here is we're taking the linear term, the middle term, and we're splitting it up into these two. Plus 4 equals 0. Right? Everybody with me? Okay. Now we group them together. Did everybody see why I put the 10 next to the 5m? Because we can factor out a 5 out of both of these. And then we can factor a 2 out of both of these. Okay, so what can we factor out of here? 5m times m plus 2. Now let's do it backwards to make sure. 5m times m is 5m squared, that's right. 5m times 2 is 10m, so we're right. Plus, and what can we factor out of here? 2. M plus 2 equals 0. Okay, now we do this and this. 5m plus 2. And again, oh, I forgot. Remember, these two have to be the same, and they are. Plus 2. And you don't put a plus or a minus in here. Remember, we're multiplying these two. Okay, so that's our answer. Right. Mm-hmm. Okay. This is where it gets kind of nasty. You put those godless negative numbers in here. If we have 15 b squared plus b minus 2. Remember, the coefficient here of the linear term is 1. We just don't write it. Equals 0. Now, what's this going to look like? The linear term here is positive. This is negative. What's our form going to be? It's going to be b plus something times b minus something. Because when you're doing distributive property, what's the last thing you do? This number times this number. A positive times a negative will give us a negative. We do a times c. A is 15. C is negative 2. That gives us negative 30. Right. Okay. We have negative 1 times 30. Negative 2 times 15. Negative 3 times 10. Is that right? 4 won't go in there. 5 will. Negative 5 times 6. That's it there, right? 6 minus 5 is 1, and that's what we want. Which one are we going to put next to the 15? Let's put the negative 5. Okay, so we have 15 b squared minus 5b plus 6b minus 2. And remember, again, I know you're sick of hearing me say this, but these two terms here are the same as that. All we're doing is we're splitting up this linear term. Now we group them together, here and here equals 0. Now what can we factor out of this one? 5b, right? Wait. 5b times 3b minus 1. 5b times 3b is 15b squared, that's right. 5b times negative 1 is negative 5b, so that's right. Now, what can we factor out of this? Looks like a 2, huh? 2 open 3b minus 1 equals 0. This are the same, so we're probably correct. Now we do groupage. 5b plus 2. And this is fun stuff. 3b minus 1 equals 0. It'd be nice to be laying up in the daybed about now, wouldn't it? But rain and cold. Mm-hmm. 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 Is everybody okay? Please tell me if I'm going too fast. Okay. 6x squared plus x minus 1. Again, for the constant to be negative, it's going to be x plus something times x minus something. Now we do a times c. Remember, this one's a, b, c. So we have x times negative 1 is negative 6, I think. Now what we want are the factors of negative 6 that add up to or combine to positive 1. Get negative 1 times 6? No. Negative 2 times 3? Yes. Negative 2 plus 3 is positive 1, so that's what we want. Now, which one are we going to put next to the 6? Put the 3 next to it. Doesn't make any difference, but we have 6x squared. Now, again, we're going to split this into these two terms. 3x minus 2x minus 1 equals 0. Okay, these two terms here are nothing more than this. Okay, 3x minus 2x or 1x, positive 1x. Now we're going to group them together. What can we factor out of here? Excuse me. What can we factor out of here? 3x times 2x plus 1. Right? 3x times 2x is 6x squared. That's right. And 3x times 1 is 3x. That's right. Now, what can we factor out of here? 1. Negative 1. That was actually a negative 2x. 2x. And negative 1 times what gives us negative 1? Positive 1 equals 0. All right. Now we have our two terms. 3x minus 1 times 2x plus 1 equals 0. All right, or am I right? I'm right. I'm always right. Okay. 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 Now you're going to get one of these on the final, I think. I haven't seen the final yet, but I shall hopefully very soon. Okay. This one's going to look kind of funky, but it's really not too terribly bad. 10x squared, I'm still working on my letters now. Plus AB minus 3b squared. Now we have two variables here. So what we're going to do is, and again, linear term's positive. The constant there, well, that's not actually a constant, but the third term is negative. So what's the form going to be? A plus b and a minus b. Okay, because remember, what's the last thing we do when we do distributive property? This times this. A positive times a negative is a negative. So we do 10 times 3. A times c is 10 times negative 3, okay, which is negative 30. Now, what are the factors of negative 30 that will give us? Remember, the the coefficient here is 1. We just don't write it. Negative 1 times 30? No. Negative 2 times 15? No. Negative 3 times 10? No. 4, 5. Negative 5 times 6? Yes. Why does it always seem like it's the last one? Okay. Again, what we're going to do is we're going to split this linear term up into these two terms. We're going to get a squared. We're going to use, let's put the 5 next to the 10 because they're 5 is a factor of 10. Minus, remember, now this is AB, so this is going to be negative 5 AB plus 6 AB minus 3 B squared equals 0. Okay, and remember, this and this are the same thing as that. Just split them up. So now we do groupage. Now what can we factor out of both of these terms here? Looks like 5a. 2a minus, was it minus a? A, stupid, b. Okay, now let's go backwards. 5a times 2a is 10a squared, that's right. 5 times, excuse me, 5 times negative b, 5a times negative b is negative 5ab. That's right. What can we factor out of these two? We can factor out a 3b. Open 2a minus b equals 0. Now we have this and this. Oh, these two the same? Yes, they are. So we're probably correct. So we have 5a plus 3b times 2a minus b equals 0. Am I right or am I right? I'm right. Okay. Okay. You do one more like this. Like I said, you're probably only going to get one of these on the final. But seems like these are a little confusing. So what if we have this? Get this if you're so smart. 6a squared minus 16, excuse me, ab plus 8b squared. Now what's the form going to be here? If the linear term's negative and the constant here, the third term, is positive, it's going to look like the form will be a minus b times a minus b. Right? Because what's the last thing we do in distributive property is this term times this term. A negative times a negative will give us a positive. Okay, the next thing we do is a times c, which is 6 times 8. You scratch your back. Oh yeah, that's good. 6 times 8 is 48. That rhymes. Okay. Now we want the factors of 48 that combine together to give us negative 16. Negative 1 times negative 48. No. Negative 2 times a negative, is that 24? No. Negative 3 times negative 16? No. Negative 4 times negative 12? Yes. Negative 4 times negative 12 is negative 4 and negative 12 is negative 16, and that's what we want. So now, which one are we going to put next to the 6? Either one, but the 12 is probably more better. We have 6a squared minus 12ab. Well, b, boy, stupid. Minus 4ab plus 8b squared. Okay, and again, these two terms are nothing more than this split up. Now we're going to group them together. Here and here, here and here equals 0. Okay, what can we factor out of both of these terms? 6a, right? There's 6a here and there's a 6a here. 6a times a, 6a times a, 6a squared, minus 2b. 6a times a, 6a squared. 6a times negative 2b is a negative 12ab, which is correct. Now, now we have, what are we going to factor out of here? Oh, should have been a negative 4. Okay, so now we factor out negative 4. Negative 4, open. Oh, stupid boy. Negative 4b, I'm sorry. What is the matter with me? Times a, I knew that, minus 2b equals 0. This and this have to be the same, and they are. So we have this and this, 6a minus 4b. I'll read this. I'm sorry, B for bonehead. Okay, and times a minus 2b. This and that equals 0. Okay? What could be more fun? Anybody want any more of these? Anybody? Let me do one more just for fun. Great fun, huh? Okay, what about this? m squared plus mn minus 3m squared equals 0. Okay. Are the linear terms positive? The last term, the third term, is negative. So what's this going to be? It's going to be plus n times m minus n. How do we know that? Again, n times negative n is negative. Okay. Right. We do a times c. Do this down here. A times c is n times negative 3, which is negative 30. The factors of negative 30, we want to add up to a positive 1. So we're going to have 1 times negative 1 times 30, negative 2 times 15, negative 3 times 10, negative 5. Can I just do this one? Negative 5 times 6. There it is there. Right? Right. Which one of these terms are we going to put next to the 10? The 5, because 5 is a factor of 10. So we do n m squared minus 5n mn plus 6mn minus 3n squared. Okay, and again, this is the same as that. So we group them together, here and here, equal 0. Now what can we factor out of this? 5m, minus n. Okay, now let's do it backwards to make sure. 5m times 2m is 10m squared, that's right. And 5m times negative n is a negative 5mn, that's right. Now what can we factor out of here? A 3n. What can we factor out of both of these terms? 3 for sure, and there's an n in each one of the terms. Times 2m minus n equals 0. These two are the same. So we put these two together. 5m plus 3n times 2m minus n. And if you want to double check and make sure, do the distributive property and it'll take you back to that. Right? Right. Now, remember one of the things that we talked about were conjugates. Terms not particularly important, but you need to watch for these. Later on, it's going to make more sense. Conjugates, J-U-G-A-T-E-S, conjugates. They are x plus 5 times x minus 5. They're opposites of each other. Now, if you do the distributive property here, you're going to get x squared minus 5x plus 5x minus 25. The linear terms here, the middle two terms, are opposites of each other. Any number minus itself is 0, so you end up with x squared minus 25. It has to be minus 25. Okay, those are conjugates. The difference of squares. Difference means subtract, and both of these are perfect squares. Square root of x squared is x, square root of 25 is 5. So if we have this, this is real simple. X squared minus 16. First of all, is it the difference of two perfect squares? Yes. The square root of x squared is x. Square root of 16 is 4. So the factors of this are x plus 4, x minus 4. Right? What about this? X squared minus 25. Both of these are perfect squares. It's going to be equal to a plus 5 times a minus 5. Right? Right. And what if you have this? C squared minus d squared. Are these perfect squares? Yes. It's going to be c plus d times c minus d. Right. Now what if you have this? Get this if you're so smart. e squared plus 9. These perfect squares? Yes. But is it the difference of two squares? No. So this is prime. It cannot be factored. It has to be the difference of, not the sum of. Okay, so if you got two perfect squares, remember it has to be minus in there. Okay. Okay. And what about this? If you have this, if you have x squared minus 8. What about that? Is this a perfect square? Yes. Is this a perfect square? No. Square root of 8 is going to be 2.8 or something like that. So it's not a perfect square. This is prime also. If they cannot be factored, the answer is prime. Okay? Okay. Okay. 25 r squared minus 4. Now, is this term here, is this a perfect square? Yes. Is this a perfect square? Yes. Is it the difference of? Yes. So this is going to be 5r plus, stupid boy. I'm sorry. Plus 2, square root of 4 is 2, times 5r minus 2. Okay. Same thing, except they're opposites of each other. This plus 2, that was minus 2. Now this is about as difficult as he's getting. It's really not all that difficult. 49 x squared minus 64 y squared. Don't have a calculator, I'm telling you, I would go and get one, because one of the things that they have on here are, will do square roots for you. First you turn it on. If you're not sure, you do square root, which is this one right here. Square root of 49 is, was it 7? 7. Right. Square root of 64 is 8. We did the square root of 64. Remember, always look up here to make sure you put it in right, because you ladies have long fingernails. You guys have big fat fingers. You got the wrong keys. You got to have fingers like a spider to work one of these things. Okay, so what's the square root of 49x squared? 7x plus 8y. Okay, square root of 64y squared is 8y times 7x minus 8y. Okay? Okay. Well, that's about as difficult as he's getting. It's really not all that difficult. Now, this is something you might see if 81 a squared minus 36. Now, what can we? Each one of these is a perfect square, so you can do it that way, or you can factor out a 9 out of this. 9 times 9a squared minus 4. Okay, now each one of these also is a perfect square. So you got 9 times 3a plus 2, 3a minus 2. I don't know why they do this, but they do. Because this can also be 9a plus 6, 9a minus 6. Same thing. Okay. This is going to take a little bit more thinking, but really not a whole lot. B to the 4th power minus 16. Is b to the 4th power a perfect square? Yes. It's b squared times b squared. Okay, so this is going to be b squared plus 4 and b squared minus 4. Same thing. Okay, what else? Okay. This is going to be a little bit different. You're going to look at this and you're going to think, holy, what in the hell? That boy has lost his mind. E-R-E-N-C-E. Sum and differences of cubes. Now, what is a cube? Two cubed, okay, the 3 there means cube. It is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. Right. So, the thing to do here is the sum of cubes. Let's do the difference of cubes first. Let me start a new page. Y'all are making me waste all my beautiful paper. Okay. E-R-E-N-C. Differences of. The differences of cubes, or the difference of cubes. It's not differences. Difference of cubes. Okay. This formula looks absolutely horrible, but it's really pretty simple. I promise. Formula, or M-U-L-A. Formula is, now this is for the difference of cubes. If you have two cubes, x cubed minus y cubed. Okay, this equals, I think that this is on one of the sheets that I sent you. The formulas are on there. X minus y times x squared plus xy plus y squared. No, it looks terrible, doesn't it? It's really not that bad. So if you have this, you have cubed minus 27. Okay, this is a perfect square, perfect cube. This is a perfect cube. Okay, so this is what we have here. Now instead of x and y, we've got a and y. So if so, what does our x equal? Our x is a cube root of. If x cubed is a cubed, then x equals a. Take the cube root of each one of these. What number times itself is x cubed? X. And of course a. A y cubed is equal to 27. Therefore, I don't know what the three dots in a triangle mean. It means therefore. We don't use that a whole lot in math, but you will in science and some of the other things. Therefore, y is, the cube root of 27 is 3. 3 times 3 times 3. Okay, so this is what we have here. This is about the most difficult part of this, and it's really not that hard. Now we just plug in take the formula, x minus y times x squared plus xy plus y squared. Now we just plug in the numbers. What's x? X is a. We have a minus y is 3. We have x squared. What is x squared? What is x? X is a. So it's a squared plus xy. Xy is a. I'm sorry, x times y, so it's 3a plus, and y squared, y is 3, so y squared is 9. That's really all there is to it. It's real simple, but it looks terrible, doesn't it? Did everybody get the xy part over here? X times y. X is a, y is 3. You put a3 there, that's okay too. Okay. Let's see if we can find E or one. Okay, here we go. A cubed minus 125. So our x here is, x cubed is a cubed. Therefore, x is a. The cube root of each one of these. And then y cubed is 125. Therefore, y is 5. Okay? We have our formula is x minus y times x squared plus xy plus y squared. Okay, what's our x? X is a minus y is 5. X squared is a squared plus xy, 5a, right, plus y is 5, y squared would be 25. Okay? Mm-hmm. Okay. Okay. Difference of cubes. So we have our x cubed is 8b cubed. Each one of these is a perfect cube. And y cubed is 27. Therefore, x is 2b and y is Is it 3? I think so. Okay, so now we have our formula. X minus y times x squared plus xy plus y squared. X is 2b minus y minus 3 times x squared is, what would that be? X squared, x is 2b, so x squared is 4b squared, right? Plus xy, 2b times 3, plus, and y squared is 9. Now, we have to do this. So we have 2b minus 3, 4b squared. 3 times 2b is 6b. That's 9. That's about as difficult as these get, and it's really not that difficult to do. Okay? Okay. Let me drop back and do another easy one. C cubed minus 64. So if x cubed is c cubed, and y cubed is 64, therefore x is c, y is 4. 4 times 4 times 4, I think. Okay, so we do x minus y times x squared plus xy plus y squared. Right? Okay. We just plug in the numbers. X is c. Wherever there's an x, we're going to plug in c. Minus y is 4. X squared is x is c. This is c squared plus xy, 4c, plus, and y squared is 16. Because y is 4, so y squared is 16. Okay? Mm-hmm. Mm-hmm. Okay. For m cubed minus 32. 4 is not a cube, perfect cube, and neither is 32. So what we can do here is we can factor out the 4, and we get m cubed minus 8. Now we have both of these are perfect cubes. Just remember, don't forget the 4 here. So if x cubed is m cubed and y cubed is 8, and x is m, y is 2. We just plug them in. So we get x minus y, x squared plus xy plus y squared. Okay. We just plug in the numbers, x minus y, so we get m minus 2 times x squared is, x is m, so we have m squared plus 2m. Y squared, y is 2, so y squared is 4, I think. Okay, now that's the difference of cubes. If you have the sum of cubes, that's a different formula, but it's basically the same. What you're going to do is change this sign right here. Well, and this one, sorry. So the sum of cubes is x cubed plus y cubed will be x plus y, okay, same thing as this, times x squared minus xy plus y squared. Everything's the same, these two formulas, except this sign and this sign. Otherwise, they're all the same. So if we have a cubed plus 27, this is the sum of cubes. So if x cubed is k cubed, then x is k. And y is, cube root of 27 is 3, I think. So now we get this. Wherever there's an x, we plug in, where is it? Okay, so we have x plus y, x cubed, stupid boy, x plus y times x squared minus xy plus y squared. Okay, wherever there's an x, we're going to plug in k. We get k plus, and wherever there's a y, we're going to plug in 3. K plus 3, x squared, that's going to be k squared minus, xy, which is 3k, and y squared, y squared is b squared, which is 9. See, those aren't too terribly bad now, are they? No. Okay. Okay, we'll do this next time. And just got just a little bit more, and then we shall review for the final exam. Okay. Anybody have any questions? Anything you want me to go back over? I'll send you a copy of the video here that we did. I'll send it to you a little bit later. It takes it a while for it to process and whatnot. So, does anybody have any questions? Speak now or forever hold your peace. Okay, y'all take care. Have a good weekend. Tengas un buen fin de semana. Igualmente, gracias a Dios. I don't know what any of that means, but it sounded Spanish though, huh? All right, bye-bye.
I have a good week.
Igualmente, gracias.
Bye. Have a good week.
Bye-bye. Thank you.
Good week.
Thank you. You too.